Question 5a part. Distinguish between parametric versus non-parametric models and supervised versus unsupervised learning with examples. Assume distribution for parametric is normal and for non-parametric is any. Assumed variance for parametric is homogeneous and for non-parametric is homogeneous and heterogeneous. Typically, data in parametric ratio or interval and in non-parametric ordinal or nominal. Dataset relationship is independent in parametric and it can be dependent or independent in non-parametric. Usual central measure. Central measure for parametric is mean and for non-parametric it is median. Benefits of parametric is that it can draw more conclusion. For non-parametric simplicity, less affected by outliers. Now, difference between supervised and unsupervised learning. In supervised learning, input data is labeled, and in unsupervised learning, input data is unlabeled. In supervised learning, it has feedback mechanism, and in unsupervised learning, it has no feedback mechanism. Supervised learning has data is classified based on training dataset, and in unsupervised assigns property of given data to classify it. Supervised learning divided into regression and classification. Unsupervised learning is divided into clustering and association. Supervised learning used for predictions and unsupervised learning is used for analysis. Algorithms include decision tree, logistic regression, support vector mechanism for supervised learning. Algorithm includes K-mean clustering, historical clustering, a prior algorithm for unsupervised learning. These are the graphs for supervised and unsupervised learning. Here, in supervised, unknown number of classes are given, and in unsupervised, unknown number of classes are present. Question 5b part. Define accuracy, precision, recall, F1 score, and illustrate their computation using confusion matrix. Here is the confusion matrix. True positive for actual positive and predicted positive. False positive for predicted negative and actual positive. False positive for actual negative and predicted positive. True negative for actual negative and predicted negative. We can assume the values for TP as 80, FN is 20, TN is 90, and FP as 10. Accuracy, proportion of all predictions that are correct. Accuracy formula is TP plus TN upon FN plus TN plus TP plus FP. By using these values, we get accuracy as 0.85. Precision. Out of all predicted positive cases, how many were actually positive? Precision equals to TP upon FP plus TP. This will be approximately equal to 88.9%. Recall sensitivity or true positive rate. It is out of all actual positive cases, how many did the model correctly identify? Recall is equals to TP upon TP plus FN equals to 80% by putting these values. F1 square, harmonic mean of precision and recall, useful when dataset is imbalanced. F1 here is its formula is 2 into precision into recall and precision plus recall. This will give 0.8. Accuracy means overall correctness whose formula is true positive plus true negative upon all samples. Here it is 85. Precision is correctness of positive predictions, which is true positive upon true positive plus false positive. Here it is 88.9%. Recall means ability to find actual positives. Its formula is true positive upon true positive plus F negative. It is 80% here. F1 square, balance of precision and recall. Its formula is 2 into P into R upon P plus R. It is 84%.